Okay, guys, let's talk about this blog post written by Jose Crespo. He's a PhD guy. This guy has been in my LinkedIn feed for a while. I've been keeping eye on what he writes, and it seems that he is a very smart guy. The cool thing about this is I was so how this guy come to my feed. So I was a C++ programmer from the beginning of my career. Doing my bachelor, I have to do all my 5 years of bachelor with C and C++. For some reasons that I don't understand and maybe I don't remember, I switched to other commoditized languages like Java and C Sharp. But the point is here, I believe that C++ is a great language. So I try to keep the pace on it, even though it's been a while since I write a single line of C++. And that's why I start follow this guy. But this guy seems to have some basis on mathematics. Oh, he seems a mathematician actually. I don't know him actually, but I want to expose him here in my YouTube channel because I think he writes a lot of cool stuff for us developers with a different perspective that we often don't get from our group of people, because a group of people that you surround yourself. Oh man, I need to learn how to make this better. Let's see. This works? This works that way? Let me see. This works. Okay. It seems that this works. The algorithm works with the filtering better when you put different color on the background. I have my book library in the background, but it seems this is better though. Okay, what I was saying. Yeah, I was saying that it's good to have different perspective. That's what I try to follow. PhD guys, mathematicians, different scientists. So we can elaborate better on the answers and on the systems that we built. So let's see what this guy has to talk about in this blog post, right? So let's share some thoughts here together. Forget programming languages. Code with math instead. For most of us, or for most of software engineering guys that I know, when they hear the word math, they got scared. And I think the main reason is because I've been working with a lot of people that are learn. So they do a boot camp on some specific language, and they somehow get into the industry. But when you talk with bachelor degrees or other type of people that has to do a lot of math to get a bachelor or something like that, the expression on their faces is different. You can tell me if I'm right or wrong, but math is just the fundamental language of the universe, guys, and you need to at least understand a little bit of it if you want to get really good in this profession. Sadly, most of the bachelor's degrees guys that I have met, even myself included, we forgot about all the math because we did a lot of math. So let me share with you. I did like seven. No, seven. In the first years, I had 7 math classes. 7. And that was insane. Just the first years of the bachelor degree. After you graduate, I barely touch math, to be honest with you. So you spend most of the time coding and fixing bugs and dealing with problems and right now in meetings. But let's see. Forget programming languages, go with math instead. The only exception, C++. Without C++, the AI/ML revolution wouldn't exist. Not just because our hardware infrastructure depends on them, so like NVIDIA GPUs rely on CUDA-C, and our vast data centers, which are the lifeblood of 21st century technology, are powered by C++, but also because the most mature, efficient, and high-performing math libraries are written in these languages. These libraries serve as a repository of multi-generational engineering and scientific achievement, bridging decades of innovation into tools we rely on today. C++, the backbone of AI and applied programming math, It's remarkable how C and its successor, C++, haven't simply become legacy programming languages, but have evolved into the backbone of today's most transformative tech advancement. They power the AI and ML revolution and underpin the astonishing progress in abstract mathematics over recent decades. I think this is totally true. Basically, AI is just somehow math done using C++ and Python. Are like combinatorics, advanced graph theory, category theory, and number theory, and modern set theory. These are, I think, and in one of the recent blog posts that I hear about, that I read about that I read from this guy, he mentioned a lot about these specific mathematical concepts, and he also mentioned that these are the fundamentals somehow that I don't know. I need to review, actually. I need to review why. But combinatorics, advanced graph theory, category theory, number theory, and modern set theory are the fundamentals, principles from math that AI and machine learning is using. So somehow we had to discover this in next chapters on this channel. Without C and C++, the AI ML revolution wouldn't exist. Not just because our hardware infrastructure depends on them, our vast data centers, which are the lifelong 21st century technology. I think we already read that. These libraries serve as a repository of multi-generational engineering and scientific achievement, bridging decades of innovation into tools we rely on today. The real deal in the world specialized and commoditized languages. So this part is very interesting for most of us, actually. I think this is one of the most important part which you should understand of this video. Whether you are in system programming or not, the solid graph of C and C++ is no longer optional, it's essential. These languages are the foundation of serious cross-domain software engineering, demanding rigor, depth, and versatility. They are not stuck chasing the latest frameworks or trends. They are the real deal when you need foundation engineer, not just disposable code. So let's think about this. This guy I know that thinks that AI is going to, so developers that understand AI and code and go into the industry coding AI models or using the AI models. This guy I know, for previous blog posts that I just read about him, is he think that those engineers will have an advantages, and I totally believe this. And the main reason is because this is the industry that will transform the future. In some way, in somehow, every industry will use the techniques used by AI, and we are seeing this, and we are just still early on this trend, right? So somehow, guys, I think we need to get on top of the AI skill set and try to read as much as possible, trying to learn how to use these languages, and maybe we need to go back and read about AI using C++ to, maybe not. But for example, if you're going to Q.C to try to build models on NVIDIA, you need to understand C, at least C. So I believe in this part he is right. Let's continue reading. On the flip side, a lot of other programming languages have drifted into being a specialized tool for predefined, standardized business domains, where creativity can feel boxed in. Look at JavaScript, for example. It's basically glued to web development, handling interactive front-end and back-ends, but rarely stepping outside those bounds. Java, that's where you will find the endless churn of crude apps for enterprises. It's caught in the boilerplate heavy enterprise trap, bogged down by decades of convention. This guy has right there. Python is undeniable a powerhouse. I really love Python, guys. I really love Python, and I think you should learn Python too, because Python is amazing. And it's fast, and it's easy to learn, and you can use it in many ways. I think Python is a mandatory skill for all of us, to be honest. Often serves as the high-level scripting layer over C++ backbone, especially in the field like data science and machine learning, alongside the mathematically grounded SQL. Then we have functional programming languages like Haskell, Elixir, and Scala. I tried to do Scala a while back, a few years back. Man, that was hard. I couldn't understand Scala. I spent a whole weekend trying to learn it, and I just I couldn't. So maybe it's time for me to step away and give it some time to this type of. I've been doing F-char for a while, and I really like it. But when you spend a lot of time programming with OOP, object-oriented programming, is really so. The switch for functional programming, it takes some time, guys. It takes some time, dude. It takes some time. So, and I think I was very hard with myself on not getting the ability to understand these languages in just one weekend, and I couldn't understand why I couldn't write a single app, hello world in Scala, and I couldn't understand the syntax. I didn't understand it. My brain wasn't working and wasn't understanding these specific languages. So, and I just move on, which I think was a big mistake. And I think you should learn, if you want to understand, if you want to become a 10x engineer, I think functional programming is very important. Even though you don't get you don't become an expert, but you need to learn functional programming, and you need to learn C++, and somehow you need to get involved on AI. Somehow you have to read articles, read books, use the models, try to write something, use Copilot. Believe me or not, there is still, I have friends that they don't use Copilot. They don't use AI to write code. Even though I write most of my code myself, I just use Copilot for a couple of things. But man, you need to use it. You need to use the tool that can give you more time and can make you more productive. Okay? And you need to use it because you need to understand how this model works. You need to understand how these specific new techniques can make you a better programmer. And most of us forget about, I understand there is a lot of person working hard to make the living, and there's a lot of people working on 8 to 5, and it's very hard when you go home and get tired sometimes to read, to learn. But guys, if you want to become a good engineer, that's how it is. This is the profession of never-ending learning. Let's continue reading. Driving it beyond the limitation of traditional object-oriented programming. Features such as anonymous function lambdas so strong the emphasis on immutable states. Immutable states. For you guys that don't know, immutable states are basically like read-only classes that can be changed when they are created. Okay, and safer computation model traces their roots back to functional programming. Applied programming math is your golden ticket. The next big thing in programming is just about learning a trendy new language. It's about getting to grips with the mathematical concepts that are reshaping how we think about code. Ideas like functors, monads, folds, arrows, and lenses. These words are weird already, but maybe he is right. And you will tell me, let me know if you think he is right or not. But if he is right, and this guy knows mathematics, and you still coding in JavaScript, and we are still coding in Java, C# or JavaScript, and don't learning these things, I don't know what's going to happen to us. Maybe this is the ticket for us to don't be removed by AI. This is the ticket to lose the fear that you will not find job in the future. Maybe it is, maybe not. Maybe this guy is right. I'm just sharing with you, share your code here, share your experience here, share your ideas here with me. But maybe he's right. So let's continue reading. Are starting to find their way into languages like C++ and Rust, pushing the boundaries of what is possible. These concepts are not just fancy jargons. They are about building code that are more flexible, reliable, and reusable. Man, I have to learn more about this. And that's just the beginning. Modern math is just making code smarter. It is completely rewriting how we approach programming. With AI ML taking center stage, we are seeing math frameworks that are solving problems in a way we couldn't before. We are a few examples of where it's already making a difference. Multi-object optimization, finding the perfect balance between competing goals. Inverse problems, solving challenges by working backward. Decision trees, quantum computing, sparse model, neural network, multi-criteria optimization, natural language processing. There is many ideas or many problems that are being resolved with this type of ideas. So instead of chasing the next flashy programming trend, focus on understanding the math driving these changes. This is not just a pacing phase, it's the future of programming. And the earlier you get into it, the better equipped you will be for what is next. Guys, let's read this, because if this guy is right, this single paragraph will tell you everything you need to hear about in this video. So instead of chasing the next flashy programming trend, focus on understanding the math driving these changes. This is not just a pacing phase, it's the future of programming. And the earlier you get into it, the better equipped you will be for what is next. And what is next? I don't know what is next, but it's highly probable that AI will be reading all the code for most of the common applications. And maybe this is the transition for writing AI that can write these applications. Maybe he is right. You will let me know in the future. Classical software developer versus math-driven developers. Multi-object optimization in actions. Let's break down the difference. Let's see how much we have left here. Okay, we are almost finished, guys. We are almost finishing. I'm not going to read the code for you, but let's... Maybe yes, why not? We have some time. Why not? Classical software development versus math-driven developers. Let's see this. It seems that we are going to get in the part of the blog that we have some specific examples. Classical software developer versus math-driven developers. Multi-object optimization in action. Let's break down the difference between a traditional software developer and one who leverages math-driven programming technique, who make it clear. We use an example built around multi-object optimization, MOO, a framework that helps you handle multi-objects at the same time by finding Pareto optimal solution. This is not just a theoretical, it's practical and changes how you approach problem solving in programming. Take this to example. MOO, multi-object optimization, allows us to balance objectives like time and energy, showing how math-based frameworks make software development more adaptable. Even though our example uses discrete variables, you can easily scale these to continuous ones or more complex scenarios. It's simple here on purpose to highlight how this technique works without overwhelming the explanation. Let's see, maybe this guy is very good explaining this type of ideas. So we might need to read more blogs about what he writes about. What makes multi-object optimization such a big deal? Every constraint is explicitly accounted for, whether it's time, energy, or something else. Flexibility, if you need to add a new object like cost or reliability, there is no need to overhaul the entire algorithm. Just plug in the new constraints, rerun the framework, and you are good to go. This is interesting. So constraints and flexibility are important. Doesn't matter what type of framework you use. Now let's see in action. Well, compare classical greedy algorithm with MOO and the same set of stacks focusing on time-energy trade-off. The greedy algorithm is straightforward and focuses on one goal, like minimizing time. The problem is ignore energy usage, which can lead to a poor or incomplete result. Okay, Pareto-based multi-object optimization. This approach considers both time and energy, simultaneously producing a range of optimal trade-off. Instead of a single rigid solution, you get options depending on what you prioritize. This example shows the fundamental shift math-driven programming enables. You are no longer locked into rigid single-object method. You can approach complex problems with flexibility and scalable tools. Task input for both algorithms. Let's break it down. We have got 4 tasks, each defined by 2 variables, time and energy. Here's the setup. So we have a vector, we have an array of, okay. task 1, task 2, task 3, task 4. Okay, this is C++. Okay, we have basically a vector of the type task that holds this, right? This is just basically like a matrix. The classical approach, greedy but flawed. First up, we run the greedy algorithm, a classic but oversimplistic solution. It prioritizes minimizing time and completely ignores energy consumption. Here how it looks in the code. Okay, well, so we have the struct task which has ID, time, and energy. We have a function compare by time. Okay, we have pass the reference of the task A, reference of task B, returns the one that has the higher time, or the lower time, sorry. Okay, we have the vector here, the grid solution sort by time and ignore energy consumption. Okay. Okay, this is very clear. So you are sorting, passing this argument. Okay, and somehow show in the console the details of the task that was greedy selected. So selected using the greedy idea. The greedy algorithm sort tasks by time and give you this output. Okay. Okay, nice. We have the output on the greedy algorithm. The problem, the greedy approach gives you a quick win for time, but it overlooks the bigger picture. That best solution might actually cost way more in energy, making it a terrible choice in a scenario where both variable matters, like real-world systems. That makes sense. That makes sense. You're using just one parameter for all the parameters that you can optimize for a single struct, which in this case is just a struct, but can be an object or whatever. Enter modern C++ and multi-object optimization. C++ functional feature, such as ranges, structure bindings, and lambdas make implementation of Pareto optimal solution efficient. We all employ a Pareto front approach to consider both time and energy. Okay, we have the same struct here, ID, time, and energy, include for ranges and views. Okay. Find Pareto optimal task using ranges and lambdas. Okay, we have the function here which receives the same vector of tasks. Defined the dominates within the function, encapsulated it within the function is better than referenced. Okay, I don't know what this is doing, but let's continue. So he basically find Pareto fronts. This is the algorithm to find using a Pareto front approach. I don't know what this is, guys. I'm just trying to understand it, which is very hard actually for me right now. But I just want to see the output to see the difference. I don't want to get focused on the code right now. I don't want to make this complex. I just want to try to explain what he's trying to show. So we have, let's go back again. So we have a greedy approach with a greedy algorithm which basically sort out the one parameter of this specific struct or class or whatever you want to call it, or object, right? And after that, we're using a mathematical approach using the Pareto, what he calls Pareto front approach. And he builds the function here, and here you can just use the function to see the output. And as you can see, the best solution is different from the one we receive here, right? So what just happened? Instead of focusing on just one variable like time, the Pareto approach considers both time and energy. This means you get a set of optimal traits of, rather than a single answer. You can now pick the task that best suits your overall priorities. Great balance for time and energy. Task 3, minimal time but energy hungry. Task 4, a solid middle ground. The bigger picture, frameworks like MOO, multimodal object, I already forget about the optimization, are not just niche ideas. They are redefining the entire programming landscape. Whether you are working in AI, ML, quantum computing, or natural language processing, this math-driven approach are shaping the future. But there is the hard truth. None of this is possible without C and C++. These languages are the backbone of cutting-edge fields, from powering GPUs with CUDA to enable the most advanced math libraries. So the next time, and here we go to the last part of the blog post. I hope this blog, you can read this blog post, because I think this is very interesting. It's going to change your life if you learn C++. And I think we are going to spend some time this year learning C++ together here. So the next time you tackle a problem, ask yourself, are you sticking to trendy, commoditized problem languages, or are you investing in the foundational skill, like mastering C, C++, combining them with real, new functional features and the powerful math frameworks that are revolutionizing programming? To ride the wave of innovation and stay ahead, understanding this tool is not optional. It's essential, bro. It's essential, bro. It's essential, bro. I'm afraid. It's essential. If this guy is true, if this guy is right, I think we have to learn C++. And if you are not afraid of mathematics, I think you have to become an expert in mathematics. Actually, you just need to understand how to use the concept he just mentioned about, like set theory, graph theory, these type of things with these new languages, and how you can use it to build these type of models. Basically, it's just a subset of all the mathematics, guys. Don't get afraid of mathematics. We have to go and learn how to use these new languages, because maybe this is the future of programming. Maybe this is the future of, maybe this is how you avoid the future. Don't be a layoff. Maybe it is, maybe not. You let me know here in the downside. Thank you for joining us today, and I see you tomorrow. Thank you, guys.